Hello, it's Adrian with another video in the series about SQL basics. We previously learned aggregate functions like count or sum. Now we learn how to group rows with a group by clause, which is frequently used alongside aggregate functions. Let's get down to it. Take a look at the example table we can now see on the screen. Each row shows a single student that took an exam in a specific subject on a specific date and got a specific score from 0 to 100. Let's try to compute various interesting statistics for this table. We've learned aggregate functions already, so we could, for instance, compute the average number of points. The query you can see on the screen now will do exactly that using the average function. The problem with this query is that it can only produce a single value, the average number of points among all exams from all subjects. Instead, we'd like to see the average for each subject separately. And that's exactly where a group by clause comes in handy. In the modified query you can now see on the screen, we've added the column subject to the select clause, but we've also added a brand new group by clause, in which we instruct the database to group all rows by the subject. The database creates virtual groups based on the column subject, and all rows with the same value are placed in a single group. Then, for each group, the database computes the average value independently. As a result, we'll get two average values, one for rows with subject, basic algebra, the other for rows with subject, advanced geometry. That was a simple example of a group by clause with a single column. Let's now take a look at a more advanced use case, where we group rows by multiple columns. Previously, we calculated the average score for each subject. Now we'd like to see the average score for each subject and each date. In other words, we want to compute the average values obtained on different examination days for each subject. Take a look at the new query. We've added the taken on column on the select clause and the group by clause. As simple as that. As a result, we'll see 6 average values, one for each examination date of each subject. Naturally, we can also use other aggregate functions with a group by clause. Let's modify the previous query to find the maximum number of points a student got on a given day in a given subject. Take a look at the query now. All we did was change the average function to the max function. This is perhaps a good moment to talk about a common mistake beginners make when using aggregate functions with a group by clause. Let's take a look at the last query we wrote. The query finds the maximum number of points in a given subject on a given examination date. Now we could say, okay, I can see the maximum number of points, but I also want to know who got the maximum score. So you could be tempted to add the full name column to the select clause in the hope that this will show the student who got the maximum score. This is not correct. The database will not associate the full name column with the max function. These are two separate things to show. Because we only group by subject and date, the database will find multiple names that could be shown in each row in column full name. And because the value is ambiguous, the database returns an error. Unfortunately, showing the student's name in this case would be more complicated. We'll discuss it on another occasion. This example leads us to a simple rule which you should always follow when writing SQL queries. All column names from the select clause which are not used in aggregate functions must also appear in the group by clause. In the latest SQL standards, you can find some exceptions to this rule, but it's still a very good practice to follow. This way, your SQL code will be clean and easy to understand at the same time. So, this was the group by clause. You now know how to use it alongside aggregate functions. Please leave a comment or a thumbs up if you liked the video. Remember to subscribe to our channel and let's learn SQL together.